Hi, how's it going? Welcome to my stream YouTube channel, however you're watching me. So it is Saturday. This is not the normal day I stream, but I'm doing an off-schedule one because I just got new toys. I got some Nixie tube stuff. So I'm going to start with an unboxing and then I'm going to hack around on them a little bit. The source code's all open source. Let's go take a look at the thing I got. Here's a package I got yesterday. I've actually already opened it and played with it a little bit. But I'm doing a fake unboxing because I hear it's the style these days. So yeah, this is what came in the mail. It is a box with a character set on it that I normally don't read and write. It's from Ukraine, I believe. Let's take a look and see what's inside. We got an instruction manual for a Nixie clock, because this is a Nixie clock kit that I'm going to be modifying to build something else with. And there's some instructions on it on how to use the clock, how to use the backlight, how to use the buttons if you have the stock firmware installed. And there's a bunch of expanded polystyrene, probably my least favorite packing material, but I understand why it's ubiquitous. And here's the actual board that's interesting. Let's pull it out, remove some of the little foam cruft. Put that down, get rid of all the foam stuff. Don't accidentally delete scenes in OBS while I'm moving things around. Bring the document projector a little closer. So yeah, here it is. This is the thing I got. It is a clock kit, but I'm actually going to be using it to make a dice roller. And it was pretty inexpensive. I got it from this website, gra-afch.com. I'll add it to the show notes. I guess you can kind of make it out there. And yeah, so it's six Nixie tubes. These are N12 tubes. They're the ones that face vertically, and they're actually socket mounted, so you can swap them out later if they break. Kind of cool. And I got one of these kits because I didn't want to spend the time. I wanted Nixie tubes to play with quickly, but I didn't want to spend the time doing all the power supply stuff. Because one of the interesting things about Nixie tubes is the power supply is like 100 and something to 200 volts. And high voltage stuff it makes it a little harder to find components. I can't power it directly off of an Arduino board or anything like that. But this thing is cool because I can play with it from an Arduino board, because you might recognize that pattern of header pins. This is an Arduino shield. So I can dust off my favorite Arduino Uno clone board, Adafruit Metro, and I can remove a couple standoffs. I can double check that there's no foam across any of the contacts, because I don't know if the expanded polystyrene will conduct electricity, but I don't want it to. And I can just plug this board right onto there. And then I can use it. And I forgot to bring a power supply. So I'm going to go grab a power supply real quick, and then we'll hack away on this a little bit more. So I'll be right back. And I'm back. So I went and got a power supply for it because this device requires 12 volts of input. One thing I didn't really realize before I started tinkering around with this project is the Arduino's main power input is pretty forgiving on different levels of input voltage. So generally, like a 5-volt input is usually what I stick in there, 5 to 6 volts. But you can put in there like up to 20 volts and it will work fine. Oh, someone's in chat. Hello! Found me from an FFmpeg video. Yep, so now I'm playing around with some Nixie tubes because it's Saturday. Why not? What are you coding on today, JM Gobel03? So anyway, moving on to this next YouTube thing. We plugged in an Arduino board. Let's power it up and just see what happens if we just power it up with. I don't think there's anything running on this Arduino board. It might have Fermata or something. Let's go ahead and just, actually, I think I will program a sketch onto it. So I'm going to make this document projector a little bit smaller. I'll move it down over here, why not? Add a little bit. Oops. Then let's go bring up, do I have an Arduino installed on this computer? No, I do not. I'm gonna go download Arduino. So you are trying to get a project to apply for an apprenticeship position in a program called Launch Code, front-end dev, cool. That explains why you were, you saw one of my FFmpeg videos, because I think that was in Cloud Functions. And like the Lambda, Google Cloud Functions, those things are really great for tying together a bunch of front-end stuff, which is actually my favorite way to build web applications these days. Because who needs back-end? Well, sometimes you do, but serverless is fun. So I need the Arduino IDE. macOS. Just download, no contributing today. Oh, you love Firebase now. I'm glad to hear that. Yeah, I use the, especially when I'm just carving out something new or for a hackathon or something, I still use the real-time database for almost everything. Even though the Firestore stuff is pretty cool. So it scales much higher, which is kind of nice. Okay, so in the Arduino IDE downloads, there's actually a sketch I'm going to go get. Because as I mentioned, I got this kit from dra-afch.com. And that's not the right website. That's a... Let's just search for Nixie clock. Or... Because that is the URL off of the board. Oh, did I typo? I probably typoed. Because web search brought it up. In the meantime, the Arduino IDE is downloaded. And they have a whole bunch of little kits. I actually got it off of eBay. That's how I found it. But they have tons and tons and tons of these Nixie tube clock kits. The one I found that I ended up picking up was one of the older versions of the 312, because it was on eBay and it was cheaper than the newer versions of the board. And they have a whole bunch of different kit versions. And they're getting started, like the documentation tutorial experience is not super turnkey, but check this part out. They have all of the drawings, like everything's available. They have like all of the schematics for the different boards up, all sorts of stuff up here for poking around and actually figuring out how these boards work, which is amazing for a commercial product to basically give everything away, which is fully awesome. And the thing that brought me to, the thing that put me over the edge on picking up this particular kit, although not many people have played with it much, all of the firmwares, all of the Arduino code they use is open source with nice confusing licensing, in that there's no licensing information. But all the sketches they use are in here. So here's their Nixie shield code. So what we can do is we can go ahead and we can clone this repo and we can install their base firmware. Let's go grab that. Open up a terminal. Clone it down. We're in code. We're in the Nixie tube thing. And now what we can do is we can... The firmware comes in a couple different flavors. They have the bin compiled, which I could upload with AVR2 directly, or the sketch, but I want to play with the sketch, so I'm going to pull that in. So Arduino IDE, let's go ahead and finish installing it. Open it up. A little closer so we can actually watch it do stuff. It turns on. And I'll make the dock projector a little smaller so I have more code. I wonder why the Arduino IDE is taking so long to start. Doing stuff though. Okay, so what we want to do is dig around in my giant pile of wires here and get a cable I can use to flash that's a really short cable. It'll work. Let's get a micro USB cable and we're going to push a program over to this board. Oop. And let's go ahead and open that sketch. Open. Back to my code folder. Nixie firmware. Source code. Nixie shield. And here it is. It's a pretty long program. With some stuff commented out. Doesn't look like there's anything too fancy in here, which is kind of nice. And some of the stuff's been pushed over to a library. Do indication is a library that has a couple functions. Do edit blank and do indication. And I tinkered around with these libraries a little bit last night. So this is going to be like 20% fumble, maybe 30% fumble, a little less fumbly than before. But there's one cool thing is there's this do test function, which is called from the setup loop, the setup function. So it's going to like initialize a bunch of stuff, and then it's going to call this do test function. So let's give, I think if we just flash this program over to our Arduino, it will do some stuff. So let's set the port, do USB serial, and see if I can program it. And it says, no, I cannot. It says, can't find, oh, I'm off the bottom of my screen. Sorry about that. It says it can't find, is there a way for me to make this bigger for easier reading? You would think so, but, oh yeah, editor font size, here we go. But how do I get the air console size bigger? Oh, interface scale. I do not know how to make the little thing zoom more. Try changing the UI scale. That seems to have done something. Okay, so I'm gonna restart my Arduino IDE and hope that that's actually gonna be legible text on this the video. Because default fonts are rarely large enough to actually read. And while the Arduino program starts up, I'm going to plug this 12-volt power wall wart style power adapter in over here. And let's try programming it again just to see if that, oh, that's a little bigger. So hopefully that's easier to read. Great, okay, so it says fatal error, click button not found, which is a library. So first thing I usually do is, Arduino has that nice library manager. I bet this would be called click button. Nope, not in there. So is it in here somewhere? There's a libraries folder, and there's some libraries here. There's a time library, which they pulled in. The click button library. Some examples. And it's GPLv3. Okay, so let's just copy these libraries into my Arduino library folder. So Arduino keeps like all its libraries. All that little library manager does is copy stuff over to, where is this? Some like documents. There's like a default path. So if I go pushd to my home directory, it's in like documents, Arduino, and there's like a libraries folder. Yeah, there it is. Oh, there's a README file here. This is where libraries go. Okay. Well, let's copy -r. From this thing, we want the firmwares. We want the libraries. Oh no, we don't want firmwares, we want libraries. Here we go. And we want to copy all those libraries here. Now there's libraries here. So hopefully it just works now. Go ahead and give it a kick, hit upload again. Gonna do its dance. It compiled successfully. So that's half the battle dealt with. Now it's uploading it to my little Arduino. And the Nixie tube just started glowing a little bit. I guess it's hard to see with all the lights here. Let me turn off the light. You can see it going through some kind of power and system test. So I'm gonna unplug it. Oh, it's making noise now too. Well, it is supposed to be an alarm clock, so that would explain why it's so noisy. The first thing I will do is disable that noisemaker, because I don't know how much that came through. It is really loud. So rather than just add a power supply while it's running, I'm going to unplug it from the micro USB and plug it straight into power, because I imagine the Nixie tubes require an actual power supply. Oh, my little board's off. But the Metros have a little on-off switch on them, and the Nixie tubes have lit up. So there's a backlight LEDs. Now it's going through a count sequence. One of the tubes is a little bit flaky. Like one of the numbers didn't just show up. The 3. So that's okay, because new tubes are not actually very expensive. But the board works really well, which is great, because it just displayed all the numbers, did some backlight, made some music, blinks little dot indicators, which is cool because this board was, I think this was $100 and something to get. This would have taken me for frickin' ever to get together. I mean, there's a lot of stuff on there, and it would have taken me a long time to get a board with this many features put together. So I'm pretty pleased with it, even though one of the tubes has the numbers doesn't always show up during power on self-test. So this is a clock, and we can hit the mode button, hear very loud beeps, and walk through the different things it can do. But I don't actually want a clock. I just got this because it was the cheapest way I could find to drive Nixie tubes with an Arduino, because I'm lazy and I love using Arduinos. And what I actually wanted to do is I want to do like cyberpunk dice. So basically I just want to display random numbers, because I have an RPG character that's like a cyberpunk hacker, shocking, and I want some in-character dice for her. Yeah, I'm that kind of nerd. RPGs are so much fun. Anyway, there is a bunch of stuff in here. We don't need most of it, so I'm going to spend the next few minutes mostly hacking pieces of this away. Starting with that tone. Like play sound, strings to display. Let's remove the sound and then re-flash it with no sound. Oh, there we go. Play music. Tone 1.play. This is a little weirdly formatted. There we go. Auto formatter. So there's a tone 1. I get a little spoiled by my ID. Keep going, like hitting go to declaration and stuff in JetBrains ID. So there's a whole bunch of these tone 1.play. There's a tone 1. There's a tone library probably further up. Let's just rip out all the code for tone. Get rid of tone.h. Oh, and this will tell us, because if I try and run it, if I remove that header, it'll give me the lines of all the places it tries to do anything with the tone. But let's try and be a little more surgical than that. We don't want a song. Keep going and removing all the tone stuff. Next. How many times does it play music? No, I don't want to drag. Select these lines for deletion. If note. That's the music. So I'll leave the loop for the music in there. I'm just gonna remove every time it actually plays music. Okay, I think that's all of the music is actually gone now. And now I'm gonna do something kind of silly. I'm gonna plug in the programmer cable while it's plugged into power, and it didn't catch on fire. That's a good sign. Because you never know when you just plug a bunch of random power supplies into each other. On these notes. Anything else? Let's see if it runs now. Upload. Okay, so I removed everything having to do with music. Hopefully it will just be quiet now. Because I'm sure that is something that would drive my co-players nuts. And it's uploading, it's going through the power on system test. Counting LEDs. Hey, that one worked that time. You know, just this one, it's just a little bit fussy sometimes, but just with number 3. And what's really weird is when it's being fussy, sometimes you can look into the side and see it arcing inside, which probably not a great thing. So I don't imagine that tube's gonna last very long. Usually when you see arcs inside anything, it's a bad sign, but I don't know. These are the first vacuum tubes I've ever owned, so I actually don't know how forgiving it is to just random arcs happening in there. So, okay, so it's not making any noise now. I can go through all the modes. No noise. Great. Okay, so let's try and understand exactly what's going on in here. So for Arduino programs, there are 2 super duper magic functions. There's start or setup. Setup, yeah, there's a setup function and we can kind of follow it through. Let's just trace the code that's in here and see what it's doing. So the first thing it's doing is there is DHV pin, which I guess is for the driver, for the high voltage. And it is setting that pin up and setting it to low. And then some commented out code is setting up the serial port, which means you could probably turn on the serial monitor and see something. And gotta set the baud to the same speed. This is at 115. So I'll set that up to 115K. Hey, it actually said something. Yay! So it's telling me that there's a temperature sensor that's reporting 0. It's counting through these numbers. This is just the test program, and it has 627 something of free RAM. And the test ended. Great. Okay, so that means we can actually log things out. Not like overloading the serial connection for the output to the Nixie tubes, which I've seen before on a couple fields. Setting up some more pins. It's reading a bunch of stuff from the EEPROM, like previous information about settings. So this is if it loses power, it'll read the old state back in. I don't want any of that. Mine's going to be completely stateless. And then it's using SPI to communicate with I'm assuming this is communicating with the clock. That's good. And set up and down, it's turning on the pull-up resistors, which I'm assuming is there's 3 buttons along the top up here, which is for setting the mode of the clock and setting numbers up and down. So I'm assuming those functions correspond to these things. Hey, we can actually see it pressing. Oh, and it has a setting mode. It can blink the numbers. That's pretty cool. And while you're in setting mode, it takes those through a little cycle too. Very cool. Okay. And this is the click button library that we had to include before. Here is it doing its stuff. It's setting a debounce time, which is just so that the physics of the button don't get multiple clicks when you click it. Multiple click timing and long click time. So long click time is about 2 seconds, which is why if I hold these down for a couple seconds, different things happen. Turns on and off the backlight, and this one goes into like a setting mode. Cool, okay. It works pretty well. We can leave most of that the way it is. A whole bunch of commented stuff out we probably don't care about. There's the do test function. I'm just gonna get rid of. We'll probably steal some code from there, but we don't want anything there. And setting LEDs from EEPROM. Find that function. Calling this function, which reads, this is the backlight, pulling it from the EEPROM. I don't want any of that, so let's remove all those references. So if the LEDs are on, the backlight LEDs are on, go find the values. I'm gonna end up with a bunch of like little chunks of like if blocks and other little code blocks that do basically nothing as I remove the actual stuff from them. But the reason I'm leaving most of the code there is because some of this might be important for timing. Oh, and here's it writing to the EEPROM. We're just restarting. It looks like it's working fine. Okay, I can keep packing. So what do I actually want this to do? I just want some random numbers. So during loop, I can probably just remove everything in loop. We'll just steal some code from the, because this is all clock stuff. There's that play music. Oh, there's a whole play music function. Let's go find that play music function and get rid of it, just to make sure it never comes back somehow. Yep, sure enough, the little music function. We don't need that at all. And is it only in one place? Only one place. Make sure I haven't broken anything. Upload it again. Still compiles. Still uploads, but does it run? And this is the code probably getting the value from the button. So I want to keep that. This is synchronizing with the real-time clock. Not using that. This is the fireworks. Let's go take a look at this fireworks function. I don't want this to catch on fire. And this is about the red, green, and blue backlight LED. That's cool. I might keep that function around. Go find the call. So it's if it's been about 5 milliseconds, do the rotate fireworks. Interesting. Comment that out for now. Might want that. Do indication looks significant. This calls the modes changer function. That's for the whole menu stuff. We can get rid of that too. Do indication is an interesting function because I think that's from that library. And yeah, sure enough, it's from that library. This is what's actually probably doing the indication. And here's actually one thing that took me a little bit of time to figure out before. Do indication, like when you call the function, there's no argument passed in. So it's like, how is it actually communicating the numbers to display? Well, whenever you pull a random library off the internet, if there seems to be some black magic going on, it's almost always global mutable state. There's almost always some magic variable that both of them are using, which is a programming paradigm that I strongly discourage people from using because like it makes bugs happen everywhere. The thing that these two things use to communicate is this library assumes there is a string variable in the global context, in the global namespace. Global scope, we'll go scope, called string to display. Yep. It also assumes it is 6 characters long. And that's how you send information back and forth. So if I ever want to change what the clock says, I just change the volume string to display and then call do indication. string display equals 1337, of course. And if I call it do indication, it'll display that. And let's get rid of everything else in here for now. Let's just make this display 1337. This is mostly about little setup clicks and stuff like that. EEPROM writes, I don't want that anyway. We can just get rid of all that because this is some branching code for blinking dots from the two different states. So if we just get rid of everything and we just run this now. Oh, but I didn't remove the test function, did I? Oh, no, I did. Test is commented out. And what do we know? 1337 is displaying, which is kind of cool. So let's display something else if we hit the button down. So how does this set button thing work? The set button is a variable, and it has a clicks value that gets set when it gets clicked. The short clicks are greater than 0. What about long clicks? Long clicks are less than 0. Interesting. So we'll just handle short clicks. Excuse me, sneeze there. So let's go ahead. If set button clicks is less than 0, or click, what we're going to do is we're going to set the string to display to, let's take this string to display and move it up to the initialization function. This is the init function. Yeah, this is set up. Let's drop that in the end of here and do a do indication up there. Format my code. And then here, what I'm going to do is every time the loop loops, I'm going to do indication at the end of my call. And I'm going to change this. If I hit that button, what I want this to say is, I don't know, 1, 2, 3, 4, 5, 6. So this will test that we have the button setting and then we can change that number display. Go ahead, upload the sketch. I love when we upload it, it displays a bunch of random stuff. And what's cool is multiple indicators are displaying at the same time when I do that. Kind of cool. There's 1337, and if I hit that button, it changes to 1, 2, 3, 4, 5, 6. Okay, so we figured out how to use this library and write some numbers up to the screen. But we want kind of like a dice roller. So in this case, what we want is random information. So what is the syntax of the random function in Arduino land? Let's go find out. Arduino random. Random. And if I was smart, I'd probably seed my random number generator properly. Well, that's a cool way to do it. You just read off of an analog value. That's cool. I'm going to do that. That is an interesting source of entropy. Probably not the best source of entropy, but it's probably fine. Yeah, I don't think there's any potentiometers on here. I don't think, are there any of these things using analog pins? There's a big table of the pins up here. If I'm using it for something I don't want. Great, okay, so I'm assuming this analog pin, analog 0 is probably just floating. So it's not a completely unreasonable source of like entropy for the random number. I think it's not good, but not better than like nothing. But that's a tricky thing with devices like Arduinos is they don't have like they're kind of stateless unless you're using stateful features. There's not an easy way for me to like keep track of the seed over time or anything like that. Okay, so we have a random seed. I think that'll work. And then we want to get a random number like that. Let's go ahead into our, not the pre-zero function, loop function. You want to get a random number between 0, or is it assumed 0? It assumes 0, so we'll just pass one argument. And the maximum we can display is 6 nines. Stick that in a long. And then we need to turn that into a string. String function and Arduino land for that. And then we can display it. go ahead and upload this. Yeah, I like the multiple indicator effect. Let's see if we can force it to happen. So when it starts displaying, displays 1, 3, 3, 7. And when we hit the button, we get random numbers. So great. So we have our RPG dice, a minimal viable product implemented. We can display it. And what's really cool about these is the numbers actually have different depth. Yeah, the Nixie tubes have a really neat effect. Because there are a bunch of different like actual wire numbers inside the tube that glow when they have the currents being passed when the voltage difference is different than the gate in front of them. Yep. Cool. Okay. So we got Nixie tubes. I don't know if I like those little dots glowing. Let's see if we can turn those dots off. Search for dot pattern. There's dot pattern. Is that another magical variable? Oh, it certainly seems to be. So where's dot pattern defined in here? Nowhere. Is it defined in header? Nope. That means that the library also assumes there is a dot pattern variable. Let's go find the initialization is up here. Is set to all zeros, which I assume means everything is out. Does it ever get changed? No. Oh, it gets changed to do.blink. Does that function ever get called? Nope. Huh. All right, let's just try messing with this dot pattern. Is dot pattern up at the very beginning? Just try changing it to turn off all of that. Okay, so in the comment, let's go ahead and do that. Upload that sketch. Because what these libraries do is it's doing a lot of kind of bit banging around back and forth, where it's doing a lot of bit masks and stuff like that. Yeah, so apparently this is a binary representation. The most significant bits in dot pattern's byte represent the off state. So, oh, but they turn back on. Okay, maybe not. Try 0, 0. Still turn back on. Okay, so there might be a bug in here. So let's take a look at when it uses dot pattern. LD equals true. When does it actually set those pins? Okay, well, there's actually the pins it's using, which is LD and UD. Let's see if they're doing anything here. LD, go all the way up. Please? Because there's actually some pins that are set. Pin upper dots and pin lower dots. So are these used anywhere? Oh, they are. The volume menu position dot pattern. Are they used in do indication directly? Only in comments. Oh, and then there's lower dot masking. Okay, if UD, else masking these bits. And then it's shooting it out to SPI. So it's just adding these dot mask values to it. So what if I just comment these out? This is where it's actually adding the dots to the byte that it then assigns to some like memory state. Oh, there's another block. Comment these all out. Oh, and some of the LEDs turned off. Half of them turned off. Yay, they turned off. That's cool. One thing I'd really like is I'd like kind of like a rolling like number when it starts up. But I want it to look a little noisy. and cyberpunk. I only have a few minutes left, but what I'm going to do is try and simulate what's happening when I program it. Because if you notice when I program it, like if I just randomly program it now, like a bunch of garbage gets out here. What I think is happening is a bunch of random stuff is getting sent out to SPI, the serial interface, which is why it's displaying random stuff. So I bet if I just transfer like random bytes, I bet if I just write I just write a 4-byte random will, the random long, it'll look pretty cool. Let's go give that a try. So where's the, here we go. Very tiny amount of code. So well, let's pick a number of iterations. Let's do it for 100 cycles or so. Do it for like, these are roughly a millisecond each, especially if I had a delay one at the bottom. We'll do it for about a half a second. What we want to do is while cycles is greater than 0, I want SPI to transfer a random number. Let's just send out a random. Well, what data type will random return? Is it a long? It's a long. It goes up to the max value. So I think there's a constant for that, but not max int, max long. Because we just want a random chunk of data. We go to integer constants. I'm just looking for a constant that represents the maximum long. Whatever. I guess I could just use like a byte representation. I'll do it the lazy way. I'll just put in what I know happens to be the integer long. I'll claim the, or the you know, the numeric value for that long. Stick that in there for now. Then we want to do, we'll do cycles minus minus. And then when it's done, it'll actually display a random number. Let's add a little delay though, so it doesn't just look like it's flickering. Let's try this. And if this works, I'll probably call it a day for now and come back and play with those backlights a little bit. Start uploading the sketch. It's going. Boots up. It says it's ready to go by reporting that it is indeed elite. If I hit the button, I get a nice little rolling effect. All flickery and stuff. I think I want it to be a little slower. Let's do 20. Actually, I'm going to do something silly. Let's do a random weight from 20 to 70. We'll do about 25 cycles. We'll make it a little bit noisier. You say you bought an Arduino 2 years ago and it's collecting dust on your shelf? That is a surprisingly common case. If you're doing, or if you're tinkering around with front end stuff, I would actually encourage you to stay out of the IDE and check out NodeBots. Johnny 5, if you're doing JavaScript stuff on the front end anyway, there are JavaScript ways to interact with electronics, and it is an awesome developer experience. So if you're just thinking about tinkering around, I recommend you go that way. So let's go ahead and flash this. This will be the last flash we do for now, and then I have a new one, so I'll be taking off in a few. But let's see if it works. So it starts up, it's ready to go. It looks, there's a nice noisy display. Looks totally cyberpunk. then it gives me my random numbers that I can use for my RPG land stuff. Yay! Okay, so on that, I'm gonna call it a day. This was tons of fun. The licensing on this code is really unclear, so I'm actually gonna ask the creator what they intend to do for the licensing before I share this code on GitHub, because I want to respect their wishes around that stuff. But I mean, they made the code available, so I'm assuming they don't mind if I tinker around on it. So with that, I'm gonna call it a day. Have a great, wonderful rest of your day. Happy hacking. And thanks for tuning in. Bye.